In the previous two videos, I talked about how to declare an interface and how to use the abstract methods declared on them. I showed that interfaces only support public, static, and final fields on them, which are constants. In this video, I'll continue to look at this unique type. Interfaces can be extended similar to classes using the extends keyword. On this slide, I show an interface Orbit Earth that extends the flight-enabled interface. This interface requires all classes to implement both the Orbit Earth and the flight-enabled abstract methods. Unlike a class, an interface can use the extends expression with multiple interfaces. An interface doesn't implement another interface, so the code on this slide won't compile. In other words, implements is an invalid clause in an interface declaration. Let's see this in code. Above the flight-enabled interface, I'll add the Orbit Earth interface. Interface Orbit Earth extends flight-enabled. Void achieve orbit. I've created the Orbit Earth interface, which extends flight-enabled, and I have one abstract method declared on this interface, the achieve orbit method. To keep it simple, above this interface, I'll create a new class called Satellite, and I'll make that implement Orbit Earth. Looking at the code, you can see it doesn't compile. Instead of picking implement methods there, I'm just going to copy the method achieve orbit from the interface just below and paste it into my class. And I'll just put a statement that orbit was achieved. I still have a compile error on this method. If I hover over it, you can see I get an error we've seen before, but maybe you've forgotten about. Attempting to assign weaker access privileges. Even though I copied this method from the interface, I didn't copy the implicit public access modifier on that method. If you don't use IntelliJ's tools to implement an interface's abstract methods, you may discover these kinds of problems. Because this method is really public on the interface, I need to specify public here. I'll do that now. Good, that fixed that compiler error, and you can see that IntelliJ now recognizes that I'm implementing a method on the interface. You can see that there's still a problem with this class. I still have to implement all of the methods on flight enabled because Orbit Earth extends that interface. I'll do that now. The default implementations are good enough for this demonstration. Although for a satellite, you can imagine the implementation of these methods might not be the same as for a bird. One other thing I want to show you is that both records and enums can implement interfaces, but they can't extend classes abstract or not. Let me show you that. Above the satellite class, I'll create a record called Dragonfly. I'll add two fields of type string and it'll implement flight enabled. Normally records wouldn't have class bodies, but because I'm implementing flight enabled, this record needs to implement flight enabled's abstract methods. I'll generate those methods. I could implement special functionality for this Dragonfly. That means it can be treated like any other flight enabled object. So that's pretty cool. This is also true for the enum type as well. I'll create an enum here above the Dragonfly record. After the enum name, I'll add implements trackable before the constants list. For the list, I'll add grounded, launch, cruise, and data collection. This enum describes 4 stages of a satellite launch. What I'm saying by doing this is that I really want each of these stages to be trackable. Like before, I've got an error because this enum doesn't yet implement the track method. I will generate that method. Let me add code in that method next. I'll just say if the current stage represented by this keyword isn't grounded. I will do some monitoring. You can imagine that you'd want to monitor each of these stages in some different way, but I'll keep this simple. I'll come back to this method in a bit, but what this means is that you can have all these various types of classes implement an interface. This means you can treat these just like other types and refer to them by the interface type. Let's loop back and talk about reference types again now that I've covered both abstract methods and interfaces. Both interfaces and abstract classes are abstracted reference types. And we know reference types can be used in code as variable types, method parameters, return types, list types, and so on. When you use an abstracted reference type, this is referred to as coding to an interface. This means your code doesn't use specific types, but rather more generalized ones, usually an interface type. This technique is preferred because it allows many runtime instances of various classes to be processed uniformly by the same code. It also allows for substitutions of some other class or object that still implements the same interface without forcing a major refactor of your code. Using interface types as the reference type is considered a best practice. In my coding examples to date, I didn't demonstrate this, and that was on purpose because we hadn't yet reviewed interfaces. I want to walk through some examples of this next with you. I'll go back to our main method and create an array list of flight-enabled types. I'll call this flyers, and I'll also initialize it, and add bird to the array list. Here, our declared type is the same as the instance type, an array list, and I've made the elements in this list flight-enabled. But array list implements the list interface, and it's recommended to use the interface type for the declared variable. I'll do that next. Same thing, but this time with list as the reference type, and I'll add bird to the list. This time, the declared variable is a list of flight-enabled elements and not an array list. List is the interface type. Okay, so why is this better? It's not really immediately obvious why just yet. Let me add some methods to demonstrate why the second declaration is better than the first. The first method I'll call triggerFlyers, and it'll have a method parameter, an array list of flight-enabled. Here I'll loop through the list, making a call each time to flyer.takeoff. This method, triggerFlyers, is taking an array list of flight-enabled things and then calling the takeoff method for each. I'll copy and paste this method, changing the name to flyFlyers, and change the method from takeoff to fly. I'll paste triggerFlyers again and call this method landFlyers, and call the flyer.land method in the for loop. So you can hopefully imagine that if you're writing an application for flight-enabled items, you might have a lot of methods that take an array list like this as a parameter. I'm going to call these from the main method, and I'll pass them the flyers variable, the first variable array list, which matches the type of the methods. I'll make a call to the triggerFlyers, then flyFlyers, and finally landFlyers. In each case, I'm passing the flyers variable, which I've declared using the specific type, the array list type. I will run this. And we get the messages for a bird for taking off, flying, and landing. Next, I'm going to copy those three statements, and this time pass the better flyers variable. Now this code doesn't compile. You can't pass a list to a method where an array list is declared. So that's one problem. Our method parameters are very specific to the array list type, but do they really need to be? For now, I'll leave those three statements as is, even though they don't compile. Let's say we've decided a linked list is a better option for us to use than an array list. I'll change our flyers variable to a linked list. And now, because our methods are specific about which type they expect, we can't pass the flyers variable to any of these methods either. We've got more errors. To pass a linked list variable to these methods, I'd have to change every single method that was declared with an array list parameter. Not fun. Next, I want to demonstrate coding to the interface. For all three methods, I'll change array list to just the list type, which is the interface type. Now the compiler errors are gone on all 6 statements, those that passed flyers and those that passed better flyers. We can pass a linked list to these methods, but more importantly, let's change our better flyers instance to a linked list. In this case, I simply swapped one type of list with another. The code still compiles, and I didn't have to refactor any other code except this one line. If you code to the interface, you know anything that implements the interface has the same set of methods, so making changes can be as simple as I just showed you here. That's a large saving of time. Method parameters, method return types, local variable references, and even class variables should try to use the interface type as the reference variable type when possible. This will make your code more extensible in the future. Coding to an interface scales well to support new subtypes, and it helps when refactoring code as I've just showed. The downside, though, is that alterations to the interface may wreak havoc on the client code. Imagine that you have 50 classes using your interface and you want to add an extra abstract method to support new functionality. As soon as you add a new abstract method, all 50 classes won't compile. your code isn't backwards compatible with this kind of change to an interface. Interfaces haven't been easily extensible in the past, but Java has made several changes to the interface type over time to try to address this last problem. In the next video, I'll be discussing what's changed with the interface type as of JDK 8.